Okay, so let's read this first paragraph, and we're going to model it with an equation. So, so it says a local museum has a special bug exhibit. Adult tickets cost $11 and child tickets cost $5. So 11 for adults, 5 for children. A group spent a total of $55 on the tickets. X represents the number of child tickets they bought, and Y represents the number of adult tickets. We're going to write a function to represent this situation. So a function's like an equation, and we're going to write a linear equation, meaning when we graph it, it would form a line. Okay? So let's get to it. I'm just going to write what this equation says, and then maybe we can dissect it. First of all, it tells us that X represents the number of child tickets. How much do the child tickets cost? $5. So to get the total for all the child tickets, it's $5 times X, the number of tickets they bought for children. And we're going to total it up, meaning add it with however much it costs for the adult tickets. And how much were the adult tickets? So this would be 11 times Y, the number of adult tickets they bought. So if we add those two values up, 5X and 11Y, that should total up to how much they spent. And they spent a total of 55. So with this equation, we could figure out all the combinations of adult tickets and child tickets that they bought. You know, they could have bought just one adult ticket and the rest were for children. Could have been two adult tickets and a few less for children, etc. So this type of equation that I just wrote is called a standard form equation. Okay, so whenever we start saying it's in standard form, it looks like this. Okay, so let's figure out like the characteristics. So this is the model for it. And the important thing I want you to remember is that A, B, and C in this equation are numbers, but they're specific numbers. They all have to be kind of draw little arrows to them. Integers. They all have to be integers. INTEGERS. But there's some restrictions there. So over here to the side, in standard form, A, B, and C are, like I said, integers. Whose greatest common factor is 1. And this is true for some, not for all. I'm not sure why they pointed out, but we'll write it. A must be positive. A is going to be positive, and B also cannot be 0. So just kind of write those restrictions. So remember, this is what a standard form equation looks like. You got some number times x plus, or maybe a minus, another number times y equals some value. And they should be integers. So we're going to be using this information we just learned, and I want you to circle everything below that's written in standard form. So let's go through them together. We only want to pick the equations here that look like this. So let's start off with this one, 3x plus 4y equals 13. Is that something that's in standard form? In other words, does it look like this? Yeah, it sure does. All right. How about this one? Is this in standard form? X minus y equals, no. We'll leave it alone. How about this one? Yeah, it says here A should be positive, but really that's kind of a strict definition. I'm going to say yes, because we will encounter something like that. How about this one? Yeah. Yep. All the A, B, and C values are integers, so we're good with that. How about this one? Kind of. What doesn't look right? The fraction there, 3/4. It can't be. It has to be an integer, a positive or a negative whole number. And 3/4 is obviously a fraction, so that's a rational number. So we'll leave that one. How about this one? Yep. So now we know what they look like. So we're going to be looking at and graphing the line that represents equations like the ones we just circled. Okay. And the way we're going to graph it is by finding the x and y intercepts. All right. So let's do that. The y-intercept is the point where the graph crosses the y-axis. Write this down, y-axis. Okay? So everyone look at the graph for a bit and follow the graph until you reach the y-axis. This is the y-axis. And it's right here. The point where it crosses the y-axis is the y-intercept. So let's just point it out. It's right there. Okay? Then we have the x-intercept, also called the root, R-O-O-T. And that's going to be important in Algebra 1, but for now, just, put it in your memory bank. Oh, that's also called the root. So is the point where the graph crosses the x-axis. The x-axis, all right? So follow your x-axis. This is the x-axis, okay? And it's right here. So this is called the x-intercept. So it says record the ordered pair of the x-intercept and the y-intercept. Okay, so each of these points has an ordered pair, right? An x and a y number. So let's start with the x-intercept. It's kind of hard to read, but we're counting by twos. So what's the value on the x-intercept? Let's see, 2, 4, 6, 8. So what would the x and y numbers be for that point? It's 8 for x. What's the y value going to be? If you needed the coordinates for that point, it would be 8, 8, 4 would be 4 up. It's 8, 0. When you're on the x-axis, your y value is 0. Okay, so anywhere along this x-axis, the y number is always 0. Same thing for when you're on the y-intercept or the y-axis. Your x value is 0. So this is going to be 0, whatever that value is. Where is it crossing? What number is that? 4. Oh, 6. You're right. Yeah. I was just thinking. It's 3 spots, not 2. Sorry it's so small. Let's make it 6. Okay, that's better. So it's 0, 6. Now that's the thing that's going to save us, because we're going to graph the lines like this. And we're only going to find 2 points, 2 locations. where it crosses the x-axis, where it crosses the y-axis, because it's super easy to find on an equation. And why is it easy to find? Because the y value is 0 for an x-intercept, and the x value is 0 on a y-intercept. Okay, so we're going to take advantage of zeros. So that's kind of what they're telling us here. It says an x-intercept will always have a y value of 0. And a y-intercept will always have a x value of 0. And we just saw that here. 0 here for y, 0 here for x. Yes? No, undefined is when you're dividing by 0, but it will, when we have an undefined slope, it is going to be a vertical line. And we're going to have one on the homework. So we'll talk about that. Thank you for bringing that up, actually. So we'll talk about that when we look at the homework. All right. So here we have an equation that we're going to graph, or they graph. They already graphed it down here. But this is the whole process. They kind of did every little detail, but the equation, let's write it a little bigger. 3x plus 2y equals 6. Okay? So the first step is find the x-intercept. And that seems like a lot of work, right? But we're going to cut that work in half. I'll show you a shortcut when we do our own. Okay, so let's talk about this. The first thing they do is they find the x-intercept, and they use the fact that y equals 0. Underline or highlight that. So first thing you do, or they did, is they write the equation. Then they take the equation, since y equals 0, they replace 0 for y. Now, let me ask you this. 0 times anything is 0. So you take advantage of that, and whatever y was goes away. 2 times 0 is 0. So then it's no longer there. So the equation goes from this to just 3 equals 6. 3x equals 6. Now, if I have 3 times something equals 6, 3 times some number is a value of 6. What does that value have to be? 2, right? 3 times 2 equals 6. So now we know what x is. X is 2. Okay? So basically, we got the coordinates. These are the coordinates. Write them down. 2, 0. We knew that y was 0, and now we know that x is 2. Okay? Any questions? Okay, focus on this. All right. Now let's find the y-intercept. Same process. You take the fact this time that on a y-intercept, x equals 0. Okay? I'll underline that. And now what you do is you take your equation, replace x with 0. So 3 times 0 is 0. So that means your new equation is 2 times y equals 6. So then you could solve it in your head. 2 times something equals 6. Well, what does that something have to be to make it equal to 6? 2 times what equals 6? 3. So y is 3. So now we know the x-intercept is 3, or the y-intercept is 3. So it's 0, 3. And if you notice, down here, you plot 2, 0 right there. You plot 0, 3 right there. You only need 2 points to verify that where the line goes. So these 2 points is where the line goes. So you graph your line all the way through. Make sure you put arrows on the ends to indicate that it goes on forever. Okay? Any questions? Let's do this. We're going to practice this. Okay? You guys ready to go on to the next page? All right. So we're going to be graphing equations. Okay. So here we are. This is our first equation we're going to graph. 3x plus 5y equals negative 16. Let me zoom in a whole lot more so we can see this. Okay, so what we're going to do is we're kind of going to make a table like they did, okay? So over here, let me just get out of the way for a bit. We're going to make the left column for the x-intercept, the right column for the y-intercept. Okay? And I'm going to show you a few shortcuts. We're not going to do as much work as they did. Okay, so which value is 0 for an x-intercept, x or y? Go back to your other page if you're not sure. For the x-intercept, which of the values is 0, x or y? Y. That's kind of, think of reverse. For x-intercept, y is 0. For y-intercept, x is 0. Okay, I'm going to write down that fact. Okay, so now, if that's true, and I replace, I'm sorry, y equals 0. Let's do that again, y equals 0. If that's true and y is 0, what's 5 times 0? 0, so it goes away. So I want you to write this equation with no 5y, just 3x equals negative 15. Write that down, right here. This goes away, you're left with 3x equals negative 15. Okay, so let's write it down. 3x equals negative 15. And now, we can solve it, or you could think it through. Let's solve it. So if I'm solving this, this is a multiplication equation, right? 3 times x. I want to get rid of the 3 by dividing it away. Remember that? And now I have to figure out what negative 15 divided by positive 3 is. X equals, what's it going to be? How many 3's go into 15? 5. But in this case, it's going to be negative 5. Okay. So now I have the coordinate for my x-intercept, negative 5, comma 0. Okay, so write that down. Negative 5, comma 0. Let's go ahead and figure out the y-intercept. So which value is 0 for the y-intercept? X or y? X. So x equals 0. So now what we're going to do is the same thing. We're going to say, okay, 3 times 0 here goes away. So what's my equation now? 5y equals negative 15. So just write the part with the y in it. 5y equals negative 15. Okay? And we're going to solve this. So I'm going to divide both sides by 5. So this cancels. And I get y equals negative 15 divided by 5, which is negative 3. So this is going to be 0, comma, negative 3. Okay? Any questions? Let's plot these points. So let's find negative 5, 0. It's right there. Oops. Negative 5, 0, right there. So that's the point we got from this. Nice and big. Okay, let's find 0, negative 3. Right here. This point here we got from this. And line up your ruler. And draw your line all the way across. And goes like that. Okay? Any questions? Okay, let's do another one together. We'll do the third one partially, and then number 4, have you try with your partner, okay? Let's do it. Focus on this, please. All right. So let's make another little t-table to find the x and y intercept. So we want the x-intercept, the y-intercept, and we're going to write down the most important fact to get the x-intercept, the fact that y is 0. Okay, so imagine you remove the y part of this equation. It goes away because you multiplied by 0. What is my new equation after that? 3x equals negative 12. Perfect. Okay, let's divide by 3 to get rid of the 3. Three goes away on the left, we get just x. Then we figure out what negative 12 divided by 3 is. Negative 4. So what's the coordinate going to be here? I'll give you the y value. It's 0. What's the x value? Negative 4. Okay. And just like that, we have our first coordinate. Let's find the y-intercept. Mm-hmm. No, it's y equals 0. Yeah. For x-intercept, y equals 0. For y-intercept, x is 0. So at the end, it's going to be 0 comma something. Okay? So now let's do that. If I replace x with 0, it goes away. What's my equation going to be? This is the part that gets a little tricky. What's in front of that negative? What's in front of the 2? Minus. That makes it negative 2y. Equals negative 12. The minuses or pluses in front tell you if it's a positive or a negative. So this is negative 2y equals 12. Or negative 12, sorry. Okay, let's solve this by dividing by negative 2. So basically I get y equals negative 12 divided by negative 2. What does that give us? 6. So this is 0 comma 6. So let's plot those 2 points. First we want negative 4 is 0. So we're going to go to x-axis negative 4 right there. Next we want 0, 6. So look for 6 up here. And that's the one we want there. Okay? And we're going to plot these points. Then graph our line. And there we go. This is the line for that equation. Okay? Okay. Let's see here. We're going to move on to the next one. So I'm going to have you set up the equations. We'll make a t-table. We'll put down the facts that y is 0 and x is 0, and then I'll have you go from there. Okay? Here we go. Let's see here.
Please excuse the interruption. Teachers, we are having connectivity issue and MySys is down. Please take manual attendance and enter it when MySys is up and running. Please do not send your rosters to the attendance office. Again, take manual attendance and keep it for your records. We'll enter it when MySys is back. District is aware of this issue and is trying to resolve it as soon as possible. Thank you.
Okay. Thank you, Ms. Garcha. So for x-intercept, the y value is 0. For y-intercept, x is 0. So I want you to write down the equations and try to solve them. Okay? So remember, you're just blanking out whichever one has 0. So in the first one, you're blanking out this part. In the y-intercept, you're blanking out this part. Okay? So go ahead and work on those. Write down the equations and then solve them. Let's plot these points. So we want to go to 3, 0. 3, 0, which is right here. That's 1 point. And then we want to go to 0, 4. 1, 2, 3, 4. Right there. Okay? So let's go ahead and make our line. All right. So hopefully you were successful in all those steps. So next, I'd like you to try this one. Let's all make the t-table together. And take it from there. Go ahead and set up and find the x-intercept and then the y-intercept. The y-intercept is going to be super simple. So I'm just letting you know that now. Okay? Give it a try. Okay, guys. So let's talk this through. So we know y is 0 for the x-intercept. So then we get rid of the y value. It's negative 2x equals 8. I divided by negative 2. 8 divided by negative 2 is negative 4. So x is negative 4. So the coordinate for the x-intercept is negative 4 comma 0. Y is actually super easy because x is 0. That means you're left with y equals 8. So they're telling you the answer there. They're telling you y is 8. So that means the y-intercept coordinate is 0, 8. So now let's plot the points. Remember, we're counting by 2's, it looks like. So negative 4 is actually here. So negative 4, 0 is there. And then we want to go to positive 8. So we go up 1, 2, 3, 4. 0, 8 is right there. 2, 4, 6, 8. So these are the 2 points for the line for this. Okay. All right. Any questions? Okay. So this is what we're going to do today. It was going to be on IXL, but we have to go to Plan B, which is, I have this worksheet.